Bitwise ORs of Subarrays. To solve this problem, we need to know firstly what does this OR behaves like. So if it is 0 and 0, 0 or 0, 0, 1, 1, 0, 1, 1. If the both bits are 0, it will result in 0, right? So if even one bit is 1, then it will result in 1. So this is how OR behaves. I think you might be knowing this, but for those who don't know, I just explained that. Given an integer array, ARR, return the number of distinct bitwise ORs of all the non-empty subarrays of array, right? ARR, right? The bitwise OR of a subarray is the bitwise OR of each integer in the subarray. The bitwise OR of a subarray of one integer is that integer. A subarray is a contiguous non-empty sequence of elements within an array. So if it is an array, the contiguous part of an array is called as subarray. As you might knew this, first thing I didn't know why does this lead code given this thing, right? Only zero as the element. So let us start with our explanation with this example: double one two, one one two. The first thing, instead of having look at the subarrays, I'll write it as 1 comma 1 as starting here. Let us not write or confuse here. So I have given all those subarrays which end at index 0. At index 1, all those subarrays which end at index 1, let me write it 1. Only this subarray, right? After that, 1 comma 1. Now, all the subarrays which end at index 2, let me write it. First thing, 2, the number itself, and 1 comma 2 is one subarray, right? This subarray. 1 comma 1 comma 2 is another subarray, right? Totally, you might get 1, 2, 3, 4, 5, 6, 6 subarrays. But let us see what are the values. We are not asked with the subarrays. We can easily get that. But return the number of distinct bitwise ORs. So 1 is only element. So our result will contain first 1. 1 is the same thing as I have already got that. 1 or 1 is the same thing. 1. I have two, right? Now, one or two. Let us see. One will be represented as 0, 1, and 2 will be represented as 1, 0. So it will result in 3. So 3 will be another one. 1, 1, 2. 1, 1 is again resulting in 1, and 1 or 1. 1 or 2 is giving me 3. So 1, 2, 3. Only the answer will be 3. Now, instead of wasting our time with this example, let us start. What if the array is 1, 2, 3? Now, ending at index 1, ending at index 0, 1, and then 2. Now, let us see. Here, and ending at index 0, only 1. Ending at index 1 is 2 and 1 comma 2. That's what I wrote there, but I am writing here 2. So 3 and then 2 comma 3 and 1 comma 2 comma 3. These are all the subarrays. But if you see what's the main pattern here, what I want you to explain is here this starting with the number itself. Everything is starting with the number itself. Every index is starting with the number itself. But if you see all those other subarrays are starting with 1, which is nothing but previous, right? Only one is took down or stepped down to the next index, which is 1. Now, if you see 2 is stepped down here to this value, if I do OR operation with the number, I would get this subarrays value. Now, this value 1 or 2 is stepped down 1 or 2 here itself. I'm making that with 3. Now, if you see, I just got that intuition, but the main thing is how do I write the algorithm for this? First thing, I need to get the result. So, what I'll do, get this result. If you see, here I stored, here I said result, I will store 1 comma 2 comma 3 and I will return the size of the result. That's it. Now, the first thing, as I said, I'll be having a result. Result will not accept those duplicate values. It might be a set, but searching in unordered set will take the less value as another set of int result. Now, what I'll do? So I am naming it as current. After that, this only current will become the previous. Now what I'll do? First thing, current will be inserted with the number which is at the index 2. I'll insert it. Now after that, I will do an or operation with the previous elements, all those elements, right? And then I would get 1 or 2, 3, right? 1 or 2 is giving me 3 and 2 is the number itself, so 2. Now all the current values will be inserted into result. Current as having 1, the number itself. So I'll just go through every number. Let me go through num in array, every number in array. The first thing is I push this 1 into my current. Previously it was my current. Let me just go through that. You might get confused, right? So current will be having the element. So every time I would take unordered set int current. So current will be having the number itself, current dot insert num. Now, what I did after that? What I did is I made current as previous, which I'll do at the last. Previous is equal to current. That's what I'll do. But if you see here, I went through all the previous elements and made into current. This current will be pushed back the current element. That's what I did first, and then went through all the previous elements and pushed that back into current. That's what I did. So this will run as current will be having 2 and then 3. Now this current will be made as the previous. Now what it will do? Current will be having 3 and then previous is having 2. So 3 or 2, 3 or 2, 3 or 1 or 2, 3 or 1 or 2, this will be pushed back, this will be pushed back into our current. That's what I did. And every time I get the current, I'll push that back into result. I'll tell you how I'll write it. So first thing, for int x in previous, just go with current dot insert current dot insert x or num, right? So I just got all those previous elements into my current. Now the result should have the current values. So for int x in current, just push that into result dot insert the x values, nothing but the current values. So this is how I get the result. And at the last, what I'll do, as I said before, return result dot size. So this is how you solve this problem. And if you have any doubts, please do comment in the comment section. And thanks for watching this video. Please do like, share and subscribe to my channel. Thank you.